Hello friends, welcome to engineering tutorial. So here is another question on displacement current. So it is given that you're given a 1 microfarad parallel plate capacitor. Okay, how would you establish an instantaneous displacement current of 1 ampere in the space between the plates? Okay, so basically we have first is a parallel plate capacitor arrangement. Okay, so there is a separation gap between them, and obviously there will be an electric field. Okay, now we are given that the displacement current is already 1 ampere. We want this. Capacitance is 1 microfarad. It is 1 into 10 to the power minus 6 farad. So here we'll have to refer to the basic expression of displacement current, see what we can do with that. So ID is equal to epsilon 0 d phi e by dt. This is the first way. The second way is epsilon 0 a dE by dt. We have already derived these two expressions, how we got these expressions in the displacement current video. So please watch that video. Okay. So here this first one we cannot use because no such information is given. The second one, we can make some manipulations in it to kind of reconvert it in a way so that we can use the data which is given in the question. Okay, let's see how we can do that. Now here if you notice this E, we know electric field intensity is voltage per unit length. Okay, that's why its unit is volt per meter. Here the electric field acts in between these two plates of the parallel plate capacitor, which are separated by a gap of, let's say, d meters. So the voltage per unit length, this electric field can be expressed as, here E is equal to V by D, voltage per unit length. Why I am writing it in this way, you will see. So if we substitute this E as V by D, then it becomes ID is equal to epsilon 0 A d by dt of V by D. As D is constant, so we will have epsilon 0 A by D dV by dt. So if you see, epsilon 0 A by D is nothing but the expression of capacitance of a parallel plate capacitor, where epsilon 0 is absolute permittivity, A is the overlapping area between the plates, and D is the separation gap or distance. So that value is given already, that is 1 microfarad. Okay, so this value is already given, 1 microfarad. So here we need a displacement current of 1 ampere. Okay, we need a displacement current of 1 ampere, and epsilon 0 A by D, that is the capacitance, is 1 microfarad. So the only parameter which we can control, that is dV by dt, rate of change of electric potential. So if we make the substitutions, 1 ampere is equal to 10 to the power minus 6 into dV by dt. That implies dV by dt is equal to 1 by 10 to the power minus 6, which is equal to 10 to the power 6 volt per second. So if we want to generate a displacement current of 1 ampere in between the two plates of a parallel plate capacitor of a 1 microfarad capacitor, then we have to change the electric potential at the rate of 10 to the power 6 volt per second. Okay, this is the thing that we have to do. Okay, so this is the thing. So friends, here if you see, we have got another expression in which we can express displacement current. So here the displacement current can be expressed as ID is equal to C dV by dt, a third way. So earlier we had two ways in which we can express displacement current, which is here in the first, which we have written, that is this one, the first way, that is rate of change of electric flux with respect to time. Here rate of change of electric field with respect to time, epsilon A, this is here only epsilon. And here we have a third expression, a third formula, which is ID is equal to C dV by dt. So remember this as well, it may come in handy when you have the appropriate parameters in front of you. You can directly put this value and get the result and save your valuable time. Okay,